All right, in this lesson, we are going to talk about direct and inverse variation. And so direct variation is something you talk about in Algebra 1. And if two variables vary directly, that means as one variable increases, the other increases. And if as one variable decreases, the other decreases. With inverse variation, it's the opposite. As one variable increases, the other variable will decrease, and vice versa. Okay, and so some common examples of direct and inverse variation we're going to look at and just fill in the blanks. And so the time to complete a job varies with the number of workers working. And so the more workers you have, if you have more workers, the time it takes to complete the job should decrease. And so this would be an example of inverse variation. Job varies inversely. And so the first variable is your y variable because it depends on the x. And so here, the time it takes to complete a specific trip varies with the speed of travel. So let's think, as we increase our speed, the time it takes to get there should decrease because we're going faster. So this is another example of inversely proportional. The cost of gas on a trip varies with the length of the trip. Well, as we increase the length of the trip, we're going to have to spend more for gas. And so this is going to be directly. The number of people invited to dinner varies with the amount of space each guest has at the table. Well, as we have more people, we're going to have less space. And so this is going to be inversely. And then the number of people invited to dinner varies with the number of pieces of silverware used. That would be direct. More people, more silverware. Okay, and so as we are writing and solving these equations, it's a two-step process. And so if variables x and y vary directly for some constant k, your equation is going to be y equals k times x. It's a linear equation, and k is the slope, and it gets a special name called the constant of variation. And so your first step is to find what that value is, and they're going to give you enough information to be able to solve for it. So here it says y varies directly with x. So automatically you can write y equals kx. And y is 15 when x is 3. So we can plug those in for x and y, and that will help us find our k value. And so y is 15 when x is 3. So we can divide both sides by 3, and we get k equals 5. And so now we have an equation we can write y equals 5x because we know what k is now. And so the reason why we want to do that is because now we can find y when x is negative 2. And so we're trying to find y when x is negative 2. So we're going to plug in that negative 2 for x, and we get y equals negative 10. And so your first step is to find k, and then your second step is to find the missing variable. Okay, here y varies directly with x, so your first step is to write y equals kx, because you see that word directly. And then they're going to give you enough information to find k. Y is negative 24 when x is 4. So we're going to fill those in. Divide by 4, and we get k equals negative 6. So our equation becomes y equals negative 6 times x. And so part 1 is done. Now find x when y is negative 30. So this time they're giving us the y value and we have to solve for x. So be careful which variable you're replacing. So y is negative 30 and we're finding x. So we have to divide by negative 6 and we get x equals 5. Okay, so for inverse variation, it's very similar, only our equation is different. And so if you see the word inversely, instead of writing y equals k times x, you're going to write y equals k over x. X is now the denominator. And so here it says y varies inversely with x, so immediately y equals k over x. And then they're going to give us enough information to find k. Y is negative 3 when x is 4. So we're going to plug those in. Y is negative 3 when x is 4. So to solve for k, we would multiply both sides by that 4, and we get k equals negative 12. And so our equation now reads y equals negative 12 over x. And that's what we're going to use to find y when x is 6. So find y when x is 6, we get y equals negative 2. Okay, y varies inversely with x, so y equals k over x. And then y is 2 when x is 7. Y is 2 when x is 7. Multiply both sides by 7. We get k equals 14. That gives us the equation y equals 14 over x. So part 1 is done. And then part 2, find, that's supposed to say x. Find x when y is 10. So y is 10, x is unknown. So to solve for x here, we need to get x out of the denominator. Okay, so to get him out of the denominator, what we're going to do is we're going to multiply both sides by x so that he cancels on the right side, and we get 10x equals 14. And then we can divide both sides by the 10. And so 14 over 10 simplifies to 7 over 5. And that would be our final answer. All right, so when you're trying to decide if a table represents direct or inverse or neither, you're looking for the equation y equals k times x for direct. And you're looking for y equals k over x for inverse, where k is just constant, okay? And so it's going to be a number. And so in general, if I were to solve for this k, in the direct case, we would have to divide both sides by the x. And so for direct variation, you're looking for the ratio of y divided by x. Those variables should be constant. Okay, because they're going to equal that k value. Whereas for inverse variation, we would multiply both sides by x. And so we end up with the product of our variables being constant, because they're going to equal that k value. And so looking at our first table, our x's and y's, if I were to multiply x times y, 1 times 4 is 4. If I were to multiply them here, 2 times 2 is 4. This is supposed to be 4/3. And so here, if I multiply 3 times 4/3, I'm still going to get 4. And then here, x times y would be 4. So because in each case, the product is constant, we know it is inverse variation, because the product is constant for inverse and the ratio is constant for direct. And so if I were to divide both sides by x, I would get y equals 4 over x as the equation. And so it says identify whether it's direct, inverse, or neither, and then write the equation. So inverse, and this would be our equation. Our k value is 4. That's the constant of variation. Right here, if I were to multiply the variables, 1 times 4 is 4, 2 times 8 is 16. So immediately we know this isn't inverse variation. And so now let's try to divide them. So we're going to do y over x. So in this case, 4 divided by 1 is 4. Here, if I divide y over x, 8 divided by 2 is 4. 12 divided by 3 is 4. 16 divided by 4 is 4. So here the ratio is constant and it's always 4. And so if I were to multiply both sides by x, I'd get y equals 4x. And so this is a direct variation. And our equation would be y equals 4 times x. So in both cases, our constant of variation was 4. But in table 1, the product was constant. In table 2, the ratio was constant. So that's how you can identify from a table. All right, the last 4 examples are word problems. And so the script, whenever the first variable is always your y, if it says the script goes y varies with x. And so that first variable is going to be your y. That second variable is your x. Another thing they may say is x and y are either direct or inversely proportional. In that case, the first variable is your x, the second is your y. I think that comes up on the homework. Okay, and so here it says the illumination I varies inversely with the square of the distance d. So be careful for that word square. Square means squared. Square root means take the square root. Okay, so I varies inversely with the square of the distance, so d squared. We can write that equation from that first sentence. Next, they're going to give us enough information to find k. So here, 1 meter away from a certain light, the illumination is 750 luxes. Okay, and so illumination is 750. When the distance is 1. So we're going to plug in 1 for d. Well, 1 squared is just 1, and then if you multiply both sides by 1, we end up with just k equals 750. And so our equation is I equals 750 divided by d squared. Part 1 is done. Step 2, write an equation that relates I and d, which we just did. Sometimes they just want the equation. In that case, you're done. Then find the illumination at a distance of 2. Okay, and so this time we're finding illumination when distance is 2. And so 2 squared is 4. And then dividing 750 by 4. We get 187.5. And illumination is measured in luxes, so be sure to include your units. Most of the time with application problems, we use decimals more than fractions. It just makes more sense in the context. Okay, here the frequency of the pitch of a violin varies inversely. So frequency varies inversely with the diameter of its string. So frequency varies inversely with diameter. Diameter is 5 millimeters. Pitch is 500 hertz. It's enough information to find K. And so we multiply both sides by 5. We get K equals 2,500. And so our equation is F equals 2,500 over D. Step 1 done. What is the frequency? We're looking for F of the pitch if the string is 15 millimeters in diameter. So we're plugging in that 15 for D. And then dividing. We get 166, and it's 0.6 repeating, and so we'll just do 667. And then frequency is measured in hertz. The number of songs on a really old iPod varies inversely. Number of songs varies inversely with the average size of a song. Okay, and so we'll do N for number of songs, and we'll do S. Be careful, make sure your S's don't look like 5s. So number of songs varies inversely with size. An iPod can store 2,500 songs. When the average size of a song is 4. So we have 2,500 songs. Size is 4 megabytes. Multiply both sides by 4. We get 100 with 2 zeros, so 10,000 for K. And so N equals 10,000 divided by S. Okay, if the average size of a song is 5 megabytes, how many songs fit on the iPod? So we're looking for N when S is 5. So N would be 2,000. 2,000 songs. Great, last one. A roof is covered by hail that is 0.5 inches deep and weighs 1,800 pounds. The hail's weight, W, varies directly with its depth, D. So this is the first time we have directly. Be very careful. Directly means W equals K times D, not K divided by D. Write an equation that relates D and W, then predict the weight of the roof of hail that is 1.75 inches deep. So in the first sentence, they gave us the information we needed to find K. So depth is 0.5, weight is 1,800. Okay, and so we divide both sides by 0.5. Dividing by 0.5 is the same as multiplying by 2. So we get K equals 3,600. And so our equation that they wanted is 3,600 times D. And then now we need to use that equation to predict the weight of the roof of hail that is 1.75 inches deep. So that's our depth. So 3,600 times 1.75. We get 6,300. And then weight is being measured in pounds. So be careful whether it says directly or inversely, and then don't forget your units.